The next tab in the configuration of this SQC chart is the Sample tab. Now I'm going to go ahead and double click on this and switch over to the Sample tab. You'll notice the Sample tab is more or less grayed out at this point. There really is no sampling algorithm to speak of when your chart is a chart of individuals, because a chart of individuals is simply we sample each value as it comes in. Now let's suppose we were looking at an X bar chart. It's a chart of averages. If we were to specify a sample size of, let's say, 4 and a time-based sampling, what we mean by this is that we are going to sample this based on a certain algorithm that is defined by these timestamps that we see here. So for example, if I'd like to start at 6 o'clock in the morning and sample every 5 minutes and then start the whole thing over again at 2-hour intervals, and actually let's go with a sample size of 5. What this means is I basically will gather 5 values, and I'll get those 5 values beginning on the hour, starting at 6 in the morning. I'll get them at 5-minute intervals, and then I start this whole thing over again at 2-hour intervals. We have a nice illustration here that describes exactly what we mean by this kind of time-based sampling. So in the example that we see right here, we're specifying a start time of 6 a.m. As you can see, that's this start time right here. That start time of 6 a.m. is specified by that sample time. Now, starting at 6 a.m., we're going to sample using the sample period of 5 minutes. That's the 5-minute interval that you see right here. So every 5 minutes, 8 o'clock, 8:05, 8:10, etc., we're sampling a new value. Again, starting at 6 o'clock, we do exactly the same thing. Every 5 minutes, we're sampling a value. And then finally, there's the calculation period. That's this 2-hour interval that indicates how long between when we start this whole process. So here's a 2-hour period, here's another 2-hour period. We started, as I said before, at 6 o'clock, and now 2 hours later, after we've done those 5 samples, we do this again at 8 o'clock. So that's an example of the Sample tab and how you can use it if you're doing time-based sampling. Now, if, on the other hand, you're simply using event-based sampling, with event-based sampling, which you would choose by choosing this right here, then you simply specify the sample size, and then that's how many values we will sample. So if you set this to event-based, I'll go over here in ProcessBook and do this. If I specify this as event-based, then we will simply sample the next 5 snapshot values that come into the system, generate an intermediate value, and then go on to sample the next 5 snapshot values. This Keep Bad Values option that you see right here, this is a toggle that simply allows you to specify whether you want values that are over range, under range, I/O timeout, those types of things to be part of your sampling algorithm. See, in other words, some schools of thought have the opinion that if you have a value that's over range or under range or otherwise unavailable, you simply keep that as part of your sampling. So you would treat it as 0, or basically if you're trying to get a sample size of 5 and 2 of the values are bad, then you go ahead and proceed with the calculation with the 3 good values. If you clear this field, then that ensures that we use nothing but good values, and good values, well, we will keep sampling until we get enough good values. So for example, if you do get 2 bad values out of 5, we'll simply continue to sample that particular sample until we get 5 good values. And of course, we're not going to advise you on that. Again, you can find a tremendous amount of discussion one way or the other within the SQC community about what's the best way to do it. Now, this filter equation field, this is used for filtering out data that is an outlier to your data. So for example, if I've decided that really the only data worth looking at is when my input data is, say, greater than 5 and my input data, stationary 1, is less than 15, then what this does is it basically only includes the data in this sampling for which that expression is true. So that's a bit of a misnomer. We call it a filter equation, but in fact the logic of the equation is that when the expression is true, that's when we retrieve data, or that's when we include the data. So by using this filter expression, of course, you can get rid of the outliers that might skew your SQC results. Now, the expression syntax that you see me using in this particular example, that's our performance equation expression syntax. So if you go out to your PI system reference, you'll find the performance equations documented in tremendous detail. But it is an expression syntax that we use universally throughout many different applications within PI. So that's what we use for our expression syntax here for filtering.